Well, thanks again, Sudipta. It's really nice to see how all these projects have come along, and thanks very much to our audience for taking the time to attend this presentation, this webinar. I think the bottom line is that we're very happy to talk about our R&D projects, and also to let you know that we're very interested in collaborating with existing and potential partners in developing our R&D program. So following Sudipta's presentation, which focused on some of the really interesting projects that we've done together with some excellent partners, I will be talking more about what we're doing in Europe. As Timo had mentioned, we have actually started this office in Germany, focused on R&D at around 2019, and the idea has been to grow our R&D footprint outside of North America into Europe. And so my presentation is largely going to be centered around what our objectives and our plans, as you might imagine, given that we've only started this a couple of years ago, that we're still in the early stages. So there isn't that much to talk about in terms of actual projects which have just started. But I really would like to take the time to give you a picture of where we're going and what the intent of this office is. So I'll start out by introducing our German office. So it was founded in Nuremberg in 2018. And the subsidiary, OPAL-RT Germany, was started to serve Germany, Austria, and the German-speaking part of Switzerland. It was a market that we saw a lot of things going on, both in terms of technology and in terms of business. And we decided that we would need a dedicated office to serve this area. But in addition to that, this office also had a strong R&D mandate. And as we mentioned, the idea was to grow our R&D base. First it started in Canada, and then in the US, and it's developing under Sudipta, made wonderful progress. And now we'd like to grow in Europe, taking advantage of the excellent institutions that are here and the various programs, so that we have diverse ideas, diverse projects, so on and so forth. So right now we're actively growing our research team, and we're developing research collaborations with industry, academic, and research institute partners. And our engagement is broad. We would be looking at the energy, automotive, aerospace, and rail sectors, to name a few. Of course, underlying this is our capability in real-time simulation of complex systems, and we do come from the power systems and power electronics background. But we do know that, especially with power electronics, there are many, many applications in different domains. So I'd like to take a step back at this point and just talk a little bit about OPAL-RT's motivation for collaborative R&D. As Timo had mentioned, it's in the DNA of the company. We invest a lot in it, and there are several reasons for this. And the first is that our typical customer is involved in R&D and advanced technology, and we see ourselves as a partner in enabling their success. So the more we work together with our customers, the more we see our customers succeeding and therefore ourselves succeeding. And this is really something that we take to heart. But beyond that, there are strong business reasons to do this. Our collaborative research projects enable us to really push the limits of real-time simulation. These projects really make us go further. You've seen some of this in the work that Sudipta presented, really, large-scale simulations, multi-time scale, with complex topologies, things like that, including advanced controls. So it really gives us the ability to push our limits and to push our product and push the technology. We also get smart on the emerging applications. We see our customers and our partners are involved in very exciting projects that are looking to the future, and it's tremendously important for us to be able to know about what's coming around the corner, to gear ourselves up to work on these technologies. And by partnering, we also have access to cutting edge research. And then we're also able to grow our team and the knowledge of our team. We're very happy to work with academic institutions, and in the past we've hired researchers that have worked collaboratively with us, and this really helps us both grow our team and maintain excellent relationships with research institutes. And put together, all this helps us maintain and promote our market leadership. And this has been proven for us. The innovations that have come from our R&D efforts have helped us maintain a very strong position in the world of real-time simulation of electrical systems. For example, we were the first ones to come out with a COTS-based parallel architecture real-time simulator. We're the first to commercially incorporate FPGAs into real-time simulation products. We've pioneered our schematic to FPGA technology, which is based on innovative use of a solver in our EHS product. And we've also developed the first real-time phasor simulator for power systems. So, spanning multiple timescales, really getting interesting technology out there to enable hardware-in-the-loop testing and real-time simulation-based testing of advanced technologies in several domains. So, so I've spoken a little bit about the motivation and where this has led us, and I'd just like to get a little more into detail of how we work with our partners. So, of course, we identify areas of R&D interest through discussions with our partners, and then we define a project and OPAL-RT Germany's role. The idea is, of course, to find a project that's interesting to both parties, that fits within our research goals, and at the same time, of course, within funding agency priorities. So we definitely work together in defining this. And then we work with our partners to develop and submit the proposal. We're actively involved in this part, and we then go ahead executing the project, keeping potential spin-offs in mind. And in our experience, we do know that research projects don't progress linearly or always in the direction that you hope for, but this isn't necessarily bad. It opens up other avenues in which the results of the project can be used, and sometimes even knowing that something cannot be done or a technology is not the best or not appropriate or not ready is also very valuable knowledge. So when we engage, we're not looking at developing a product and pushing it out the door. There are multiple levels on which we engage in these projects, in terms of building knowledge, in terms of getting other creative ideas out of the projects, and so on. And finally, when we do execute these projects, we look at what we can do with the results. And working with partners and our partners network enables us to really assess the commercial potential of results that could come out of research, and also work with our partners and partners network to turn these technologies into products or services that can be transitioned to the industry and help with the process of developing advanced control systems or advanced power electronics or whatever area we're working in. So what are our R&D focus areas? Now, as all of you know, or many of you knew, we're in the business of real-time simulation, of complex system simulation. So underlying all this, solvers and numerical methods are a big part of what we invest in. This is very important to enable fast and real-time simulation of complex systems. And on the other side of it, it's also modeling methodologies, the best way to build models, taking into account the trade-off between fidelity and speed of execution, which is so important for real-time simulation. And then we're also looking to diversify our applications, for example, into cyber physical systems, as Savita mentioned earlier, things like that. So where can we take real-time simulation in the future? Where can we use all the technologies that we've developed and apply them in creative and innovative ways? And then we also have to look at hardware implementation. Real-time simulation and hardware-in-the-loop simulation isn't just about software and numerical methods, it's also the implementation. We have to worry about latencies, we have to worry about interfacing with various devices, large numbers of devices. And so this comes down to hardware design too, with IOs, power amplifiers, building integrated test benches, optimizing how the hardware works, so on and so forth. So these are some of the focus areas. And across these, we're looking at how emerging technologies can be used to do this. And of course, there's artificial intelligence, which could be used to generate test cases, maybe used for model tuning. We have to handle, for example, in Sudipta's example, where we were doing a simulation of a 600 or 1,000 or a million node system, there's a lot of data. You're measuring a lot of voltages and currents across the system, and you have to handle a lot of data. You have to handle a lot of parameters. You have to validate them. And there are big dynamics too when you have such big systems. And this has to be handled. We're also looking at how cloud-based simulation can be used and which timescales are appropriate for it. And finally, advanced hardware architectures, as I'd mentioned before, and perhaps in the future, even looking at things like quantum computing and so on and so forth. But this is just to say that the way we look at it is that we have our focus areas, and then we try to see how emerging technologies can be utilized to develop our technologies or the technologies that go into our products. So just as an example of one of the first projects we've kicked off in Germany with the Flexible Electrical Network Consortium, which is a research consortium at RWTH Aachen, one of the leading universities in power systems. This project has been funded by the German Federal Ministry of Education and Research, and it's called DC-SEC. And the project objective is to develop converter and system level controls for DC and hybrid AC-DC grids with a cybersecurity aspect. And so this involves multi-timescale simulation because we're looking at both the system and the converter level. And it also includes simulation of the communication networks for the cybersecurity aspect of it. And we're looking at simulating large numbers of converters and relatively complex grids. So this pushes us to develop very computationally efficient real-time models, and also motivates us to look at better solvers, better ways of handling such simulations. So this is the first project that we've kicked off in OPAL-RT Germany, and we have a few more ideas in the pipeline, which would be turning into proposals. We're looking at life extension of power electronic converters using advanced control and monitoring. So this involves not just modeling power electronics, but also looking at aging effects and so on. And then we're also looking at combined phasor and EMT simulation, or the use of dynamic phasors, which span in some sense both EMT and classical phasor simulation, help you to look at dynamics that are in between. We're looking at intelligent test automation. How do you create test cases automatically that are meaningful? We're looking at cyber physical security, then also at systems like more electric and electrically propelled aircraft, which bring their own unique challenges in terms of protection and control and redundancy. And we're also looking at hydrogen storage integration in the electric grid. And there's several other topics. So this is just a snapshot, but as I'd mentioned before, we're looking at the energy, automotive, aerospace, rail sectors, and we're interested in seeing how we can develop our knowledge and our projects in these different domains. So, just to sum up from our side, we keep repeating it, but it's true that OPAL-RT is R&D driven. And we're very interested in partnering and executing collaborative funded R&D projects. We're actively engaged in expanding our footprint, and we're continuously looking at pushing the boundaries. And all this is because R&D collaboration is a key component of OPAL-RT's success. So I hope this gives you an overview of the way we look at R&D, where we're going, and in combination with Sudipta's presentation, which gave you an insight into specific projects we worked on, you're able to see how OPAL-RT is involved in R&D And we're very happy to discuss potential projects in Germany or Europe with us. This is, you have our contact information here. You can contact myself or Timo, and we'd be very happy to talk to you. So with that, I will conclude my presentation and hand it over again to Timo to take care of the question and answers session and conclude the webinar. Thanks very much again for your attention.